Welcome back. In the second video on geometric optics, I want us to discuss reflection. Now, reflection is basically the bouncing off of light from an object. So here we have a photo of a beautiful reflected image in the water of that mountain covered in snow. Now, with reflection, you need an incident ray. There will be a reflected ray, and there is a normal. The normal is usually to the perpendicular line to the surface of the reflecting medium. The incident ray is the light moving towards the reflecting medium, and the reflected ray is the light moving away from the reflected ray, from the reflecting surface. Now, these things, the incident ray, the reflected ray, and normal, must lie in the same plane or flat surface. So I want us to look at smooth plane reflection. Firstly, here we have a light source. And it sends a beam of light towards the mirror. So this is the incident ray. I'm going to number it number 1 and say 1 is the incident ray. So you would draw a line using a ruler Now there, where this incident ray hits the mirror, that is where you need to draw your normal. Your normal is this line that is perpendicular to the plane mirror. The light that moves away or that bounces off the mirror, that is called the reflected ray. Okay. Now, the next thing is the angle of incidence. Now, by definition, the angle of incidence is measured between the normal and the incident ray. So this is the angle of incidence. And for this example, we can see that if we count from 0, it's 10, 20, 30, 40, 50 degrees is the angle of incidence in this case. So just to remember that the angle of incidence is always measured between the ray of the incident light and the normal. Now, although I named or labeled the normal at the bottom here, I could also have said that that is the normal because this is my reflecting surface there. Now, the angle of reflection is between the reflected ray and the normal. So I'm going to say theta r. And if we measure it using the protractor they've got here, it's from the 0, 10, 20, 30, 40, 50 degrees. So for reflection, the angle of incidence will always be equal to the angle of reflection. Next, I want to look at the ray diagram you will draw in this case. So the ray diagram for plane reflection looks as follows. If you've got the mirror, your reflecting surface, the angle, the incident ray would be this one. P is the incident ray. It hits the mirror. The angle of incidence is measured between the normal and the incident ray. And the reflected ray is Q, and the angle of reflection will be measured between the normal and the reflected ray. Next, I want to look at the reflection of a rough surface. Now, when you look at a rough surface, you will not see a clear image in that surface. Why not is the big question. Now, a rough surface scatters the reflected ray. So you can follow any arrow there that is incident onto the rough surface, although it obeys the rule where the angle of incidence equals the angle of reflection. Because the surface is rough, the normal is never in the same direction. So you get the reflected rays scattered in all directions. So you can't form those rays can't form a clear image of the object that is in front of them. Okay. Now, the law of reflection is the following. The angle of incidence equals the angle of reflection, and the incident ray, reflected ray, and normal lies in the same plane. Basically what we have discussed up to now. Some applications of curved surface reflections. Firstly, the telescope mirrors. Telescopic mirrors look like that. They could be bulging inwards or outwards. This one is bulging inwards. There you've got the light coming in from afar, and the curved surface will reflect the light through the focal point of that reflecting surface. So you would see an upside down image of the object. Basically, that is why your eyes form upside down images on the retina. Next, the headlights of cars. Now, the difference between a telescopic mirror and the headlight of a car is with the mirror, the light is coming from afar. With a car's headlights, the light is at, the bulb is at the focal point. So what happens is the light is reflected parallel from the surface. So all the reflected rays would run parallel to each other. So that beam of light is a rather strong beam of light. Just two applications of a curved surface reflection.